Rajkumar, you can, no problem. So guys, this is our session number 5 on fluid mechanics, and yes, Samarpita will be discussing. We'll be showing you the results in some time. Yes, I was traveling in the morning today. That's why I look a little tired because I had a very early morning flight and had to could not sleep properly. So maybe today when I sleep properly, then maybe I'll be back normal. And yes, results take absolutely everybody is happy. So will all Vedantu students be promoted to Eklavya or not? No, everybody doesn't get promoted to Eklavya. There are certain criteria that you meet, and after that you are taken into Eklavya batch. But that time will come. We'll let you know guys when the Eklavya batch admission start. Okay, everyone. Yes. So everybody, let's start. Everyone is ready. Everyone is ready. Let's start the session. Everyone. Great. Awesome. Chalo, everyone. So switching off the chat and yes, switching off the chat and now stop writing things on the chat box, everyone. Okay, chalo. So a quick recap as always. Last time what we were discussing, we talked about the last topic of fluid statics. When fluids are stationary, we spoke about the buoyancy, Archimedes principle, and the law of flotation. We understood that the buoyancy is because of the liquid pressure, and because as the body is submerged in the liquid, the amount of pressure which is experienced by the body on the top of it and on the bottom side of it are different, because of which there's a net upward force which is experienced by the body which is submerged inside it. So when we try to calculate this buoyant force is equal to density of the liquid into volume of the body submerged into G value. Always remember this. The amount of volume of the body which is submerged, or the amount of volume of the liquid which is coming out or which is displaced because of this, because you have to accommodate that solid body inside, that much amount of volume is to be taken into account. If the entire body is submerged, then no problem. Then the volume of submerged is equal to the volume of the body. Otherwise, you have to be very careful with that. Okay. And then we spoke about the law of flotation, that when we say that the body will be able to float, when the buoyant force of the body is able to balance the weight of the body completely, in that case, your body can float. Usually, we will say that the body will be able to float when the body's density is less than the density of the liquid. In that case, there's absolutely the body is going to be floating. If its density is just equal to the density of the liquid, then also it will float, but its entire volume will be inside the liquid. Okay, everyone. So very small things we studied last time, and based upon what we learned in the previous class, there are a few questions that you will answer. Then we'll move forward and we'll start fluid statics, fluid dynamics. Today we'll start talking about situations when your fluid starts to flow in a given given pipe or maybe in a given possible region to flow into. Okay, so everyone, question for all of you guys to solve first. This says that we have a block whose density is 500 kg per meter cube and dimensions are given in the diagram. So if it's half of the portion of the solid body submerged in the liquid whose density is 800 kg per meter cube, then we have to calculate the buoyant force applied by the liquid. Obviously, the buoyant force acting will be upward. What will be the value of this buoyant force? You have to talk about the volume of the body which is submerged. So density of the liquid, volume submerged into G is what you want to calculate. Okay, giving you guys 90 seconds to try this. Okay, quickly get onto it, and the time starts in 3, 2, and 1. Come on, everyone. Okay, almost half time is gone. 45 seconds remaining. Okay, last 20 seconds now. Everyone, come on. Okay, and the last 3 seconds. Time is up. Let's see. Okay, that's nice. Okay, so guys, the correct answer is option B, and it's very simple. Only part that you needed to calculate properly was volume submerged. Okay, so volume submerged is basically 5 into 5 into 2. Only this much height will be taken into account, the amount which is submerged. So this comes out to be 25 into 2, and you'll have to multiply by 10 to the power minus 6 to make it meter cube. So 25 into 2 is 50 into 10 to the power minus 6 meter cube. That's basically the volume submerged. So we'll multiply this with the density of the liquid, that is 800, and G value, so we'll get the answer. The G value is 10, the density is 800, the volume, when you multiply this, you get the answer as 0.4 Newton. That's the upward force which is experienced by this body. Okay, everyone. Now this one. This one says you have to calculate how much portion of the solid body, cylinder body, is submerged in the liquid of density, which is 3 rho. So how much is the value of this X is what you want to find out. So before you approach it, I'm giving you a hint that maybe X amount of that length of the cylinder is inside the more dense liquid, and the remaining amount is going to be L minus X. So correspondingly, when you will calculate the buoyant force, FB1 plus FB2. So FB1 and FB2 will be calculated according to the volume submerged individually. Okay, so this is going to be maybe V1, this is going to be maybe V2. So you'll have to accordingly calculate the value of V1 and V2 to write down the value of buoyant forces acting upward. Will be equated to the weight of this cylinder whose density is given to us as 2 rho. The density of the cylinder is also given. So when you are trying to write the mass, you will say it is density into volume of the body. Okay, so you will be required to do that. I'm going to give you guys complete 2 minutes for this, and your time starts in 3, 2, and 1. Come on, everyone. Seconds still remaining, everyone. Seconds more, everyone. Okay, and the time is up. Let's see. Okay. Oh my god. Oh my god. Okay, guys. So it wasn't that challenging as the overall tally says. The correct answer to the question is option D, that is L by 2. So you will see that when we try to write down the volume of the upper part of it, the volume V1 will be equal to the liquid volume, which is displaced, will be written as per the cylinder, which is submerged volume. So the length is L minus X and area of cross section is A. And if we write V2, the lower portion of the cylinder, it is X into A. So when we try to write down FB1, we'll say it is rho into L minus X into A into G, and FB2 will write as rho into X into A into G, and Mg, which you will be balancing it with, will be equal to 2 rho. My bad, this is 3 rho. The second liquid has density of 3 rho. So 2 rho is the density of this body into its volume, that is A into L into the value of G. This is mass multiplied by G value. So all of these things will be put together now. So rho into L minus X into A into G, 3 rho into A into X into G, and 2 rho into A into G into L. Things which will get cancelled, we'll simply cancel them out. So rho G A is a factor which is throughout getting cancelled. Okay, everyone. So you'll be left with L minus X, you'll be left with 3X, you'll be left with 2L. So L comes to the right hand side, becomes 2L minus L, that is L. And 3X minus X, okay, 3X minus X will be 2X, and that is why the answer comes out to be L by 2. Okay, everyone is clear? Everyone understands? Quickly in the chat box. Everybody? Yeah? Awesome. All good. Now, as we were, okay. Yes, Ishika, absolutely. Okay. So rho is density of which? Rho is the density of liquid number 1. And 3 rho is the density of liquid number 2. And 2 rho is the density of the solid body which is inside it. Okay. Sir, are you okay? What happened to me? I look a little tired. Yes, I am tired because I traveled today early morning. That's why. Okay, but I'm absolutely fine. Okay. Yeah. Their voice is different because you guys were listening to me from Bangalore, where they had like very good mic. The microphone was really nice there. I'm actually planning to order one today, right? So I'll be getting that mic, and then you will be able to hear me. When I'm having water, you'll be able to hear me breathing. Everything that you guys were giving your feedback that day. Okay. Yes. And one of the reasons of taking the class is that I want to actually get back to normal. So when I take the class, I obviously feel normal with you guys. That's why. Okay. So chalo, let me show you guys the results of 2021. This year, Vedantu has actually created history in the space of online teaching, and your very own Vedantu has actually done, which was never thought of before. In fact, when I was there in Bangalore, we all were celebrating the result. We were discussing it with Vamsi Pulkit and AP sir. They were actually telling us the story that when we started, we did not even imagine that within a span of 6-7 years we'll be able to get into triple digit ranks or the triple digit numbers. We have the double digit rank this year. Okay, so the history has got created, everybody. We have not just surpassed the previous year result. We have actually taken the number much above what we actually expected. We expected close to 1200 students from Vedantu this year. We could definitely crack the examination. Okay, so this year students have actually rocked the show, and it is extra special because most of the students across the country have prepared online, and Vedantu, as you all know, is one of the leading and one of the biggest platform for learning online for JEE examinations. I'm sure that you guys are feeling the difference that it is unlike any other place where they are teaching on Zoom platform, they are teaching on I don't know which other platforms, but here we have made sure that we have our own platform we are learning, and that is why not just the teachers, not just the backend team, the platform itself is so amazing, right? 1500 are under 10,000. No. These are the overall selections, obviously. These are not under 1,000 or under 10,000. Okay, I dance, but I'm fortunate that I was not in the video, because if you would see me dancing, you would be like, okay, sir. Now we can actually stop dancing. So guys, a very, very awesome, fascinating fact I want to share with all of you guys, that this year all the people who are going to get into ITs, 6% of that janta is going to be Vedans. So when they'll be interacting with each other, they will definitely find a lot of their batchmates whom they physically did not meet. So you guys don't physically meet with each other, but then in such cases, people will be meeting there, and then they will get to know that he was studying in some other city, but was studying with Vedantu, he or she. So that's the kind of thing that's going to happen this year. Okay, and the best rank this year we have actually improved on the previous year. Also, previous year we had 42nd rank, and this year we have 35th rank. This guy Prerak, he has actually improved his JEE main rank. He got rank 243 in JEE main, and in JEE advanced he has actually improved his rank by good margin. Okay, I was wearing a green shirt. Okay, that's nice. So okay, but the one of the most highlighting results this year that we have, one of them is Priyanshu. Priyanshu, you look at his rank in JEE main, guys. You just look at his rank. He was like about 10,000 rank in JEE main, and from there he has done amazing change in his own performance. We were surprised, absolutely surprised that a guy like Priyanshu, I can say that he must have definitely put a lot of hard work, a lot of efforts must have been from him also, and definitely the teachers who are working in the background has helped him a lot. So hence we can say that Priyanshu has won our heart. He has actually made a crucial difference in how online education is perceived by actually taking him here. Okay, he was under the guidance of Vikas sir. Okay. So everybody, how are you guys feeling? I think this deserves to have a round of dole. What do you say? It deserves a round of dole. Yes, awesome. Yes. So yeah, you guys have to make sure that everybody in your circle who believes that teaching or studying cannot be happening for JEE online, but then you can be very proud, very confidently. You can actually tell everybody that things are happening online as well. Things have changed. Okay. Yes. Awesome. Yes. Okay, and yes, this also goes with it. Yeah. So great job by Vedans. So next year will be your turn. I know that many of you guys are, you have many questions about Eklavya batch and everything. So let me just give you a brief idea, everybody. Okay. Yeah. So let me also tell you about Eklavya batch. First of all, let me clarify, all those 1,500 students who have qualified for JEE Advanced or from JEE Advanced, they're not all Eklavya students. Let me put it that very, very, very honestly. Okay. Not everybody is a Eklavya student, because in Eklavya there are very limited number of seats, very limited number of students are actually taken into that batch. There's a very rigorous criteria, very rigorous interview process which students go through. Okay. So that is why I do not even think that all the students who have clarified or cleared this examination are Eklavya students. Many of them are, but not everybody. Many of them are not Eklavya students, and still they have achieved what they wanted to. So that's point number one. Second point is, you definitely must be wondering that how do I get into Eklavya batch when the time comes? First of all, Eklavya batch is not formed in your 11th standard, and even when your JEE syllabus is getting completed in 12th. Like right now, the people who are in 12th standard, they still are not into Eklavya batch. You're just 1 year senior. The people who are in 12th standard right now, their Eklavya batch is not yet formed. When does Eklavya batch get formed? Is when JEE main happen for the first time. Now, ideally, you know that JEE main happens twice. This year was extra special, but otherwise JEE main now happens twice. Once it happens in the month of January, second it happens in the month of April, and then in the month of May. Advance is supposed to happen. For the last 2 years, because of COVID, things have been very different. So in the month of January, when JEE main happens for the first time, its results come within 1 month. That means by the end of January month, the results are out. So on the basis of the percentile that you get in JEE Main for the first time when you officially appear for that examination, on the basis of that we invite application from students by asking them to fill a Google form. On the basis of the percentile, on the basis of the the overall source taken by the students are contacted by the backend team of Vedantu, Eklavya team. Okay, and they talk to students, they interview the students, they discuss it with them, and then there is a test through which they are being taken into. Okay, and passing all these criteria, you are taken into Eklavya batch. Simple words for you people. Eklavya batch will be formed in the year of 2023 January month. Okay, so 2023 January month will be the year for all of you to try for doing good in JEE Main for the first time, and secondly to appear or apply for JEE the Eklavya batch. Okay, the points clear to everyone. When does the Eklavya batch happen? Eklavya admissions happen, and what not, right? So as of now, just focus on what you're doing. You are absolutely getting the same treatment which everyone else is getting. Okay, if you want to be in the toppers batch, speak to your SAM. They will be the person who will be able to give you a better clarity about how the topper batch is being created when they are being formed and everything. Okay, fine. So same thing, internal students from them, the toppers batch are accordingly created. Benchmark test is something which you have to definitely keep on appearing for. And overall, your annual performance matters in the selection of toppers batch as well. Okay, everyone is clear with it, right? Yes, you should not worry about anything right now. You should only be focusing upon what you're doing. If you will worry, you will definitely not be able to perform as per your potential. Is that clear? Okay, absolutely clear to everyone. Baki ke sawal you can ask me at the end of the class. Okay, you can ask me at the end of the class. Cool. Yes. Chalo everyone, switching off the chat and taking today's class, which is already 24 minutes gone. So today's discussion is going to be about the fluid dynamics. We'll be speaking about situations when the fluid starts to flow. So first thing that we'll be speaking about will be streamline, or we also call it laminar flow, and then a brief introduction of turbulent flow. Ideally, this discussion should not be happening today, but I want to give you a brief idea about it because this discussion happens when we speak about the real fluids. Okay. Then we'll speak about something called as equation of continuity, a very interesting phenomena, and related to that, or it is going to complement the other thing which we call as the Bernoulli's theorem or Bernoulli's equation, a very beautiful equation, beautiful theorem. Its application is something that we'll be studying in the next class also. Okay, so first of all, let's understand that what is a streamline flow, what is a turbulent flow. Streamline flow is basically the one where we can say that the fluid is traveling in the form of layers. Fluid is flowing, and it is flowing in the form of layers, but they are not intermixing with each other. So it's a very steady flow. Okay, that flow is what we call as the streamline flow. Don't worry, on the left hand side there was supposed to be an image which is not here because of certain reasons. Okay, maybe due to the high quality of the graphic image file, that's why it's not loading. And the second one is basically the turbulent fluid flow, which is basically the one where you can say a lot of turbulence is going to happen. The fluid, when it is going to move, it is going to look scary. It's going to look very intermixed when it is flowing from one point to another. So what exactly is your streamline flow, or we also call it, I'll write it down here, or laminar flow. Both are the same things. When we say streamline flow, at times you might in the questions in some certain books you might find this term laminar flow also written. So at that time do not get confused. It's basically speaking about the same streamline flow also. So what exactly is streamline flow? Let's read it first. The flow is said to be steady for a fluid if at any given point the velocity of each passing particle remains constant with time. That means what? Say when a liquid is flowing and there are different points in the flow. Means when we physically put our camera here and the liquid is passing by, if it is a streamline flow, whenever a fluid particle will cross this junction, whatever be the particle, whatever is this particle crossing point P, the velocity at this point of each and every particle while crossing this point will remain the same. Means if a particle is crossing, the first particle is crossing this point with a velocity of 2 meters per second, the second particle, third particle, fourth particle, whichever particle will cross this point will have a velocity of 2 meters per second. Maybe going forward the velocity becomes 4 meters per second, but every particle after reaching the next point that is Q, every particle will have the next velocity that is 4 meters per second, so on and so forth. So with time, at that point, the velocity of the different particles will always be the same. Okay, I'm not saying that particles will not accelerate, they will, but at a given point in the tube, the point will always define that velocity to remain constant, and that defines the streamline flow. Okay, so that's what it says, that the velocity of the particle may change as it moves from one point to another. But when it is crossing, say, point A, all the particles when they cross point A, it's basically a tube in which liquid is flowing. So all particles when they cross point A, they will have a velocity V. Similarly, B, B, C, B, D, and B. This velocity may be same at time and they may not be same also. Okay, so every other particle which passes the same point behaves exactly as the previous particle that just has passed the point. Okay, give you a graphic image file to give you the idea that when maybe this point is being crossed by, maybe this point is crossed by, maybe this point is crossed by, you can see that the central particles are moving relatively faster. Okay, but all these particles when they will be crossing point A, they will have the same velocity, the particles which will pass through this point. But maybe through point B, the different particles will pass through point B. So in that case, maybe velocity at A and velocity at B, the different particles will have different velocity. But whichever particle will come to point A will have the same velocity all the time. So maybe here the velocity is 2 meters per second. So every particle which crosses point A will have a velocity of 2, and maybe there at point B the velocity is 3. Such is basically what we call as the laminar flow or the streamline flow, and this is where the intermixing of the layers of the fluid will not happen. Okay, the diagram right now which is being shown in front of you is actually drawn for a real fluid. It is not for ideal fluid, because for ideal fluid the velocity profile, these vectors that you see, they are representing the velocity of the particles. So as the fluid is flowing, the velocity of the central part is more comparative to the one particles which are in the contact with the tube. Why? Because there will be practically viscosity. There will be some resistance offered by the surface of the point. Okay, just a second, guys. I'm getting a very urgent. Guys, just So sorry guys, let me just set the context also that why was that call important, because it was from my previous boss. That means Lakshya Institute. You all know that I've taught in Lakshya. So the person whom I used to report to, he called up to just check up that how Suri sir is doing, how is he, and how has been the results and everything. So he was just calling me after a long time. So that's why I had to take a call, because obviously that person is usually a very busy person, and if he's giving a call, you are supposed to pick it up, right? It's like me, if I give you guys a call ever, then definitely you would stop everything that you would be doing. I'm expecting that, and you will definitely pick up my call, right, everyone? If ever you'll get a call from one of the master teachers, you will definitely pick up the call, right? So that's the kind of situation that I was into, and that's why I had to. Okay. I will speak about everything at the end of the class. If you have more questions to ask me, okay? Chalo everyone, we are already running very slow for today. Let's quickly move on to the further discussion. We have so far understood what is streamline flow. We have understood this part, right, everyone? Now let's speak about further what are streamlines. So streamlines is basically trying to visualize how liquid flows. So obviously liquid is entirely a three-dimensional thing which is flowing in the space. But if you want to visualize it, just like gravitational field lines. So if you want to visualize how the liquid is flowing in a streamline manner, you will accordingly to the flow of the liquid, you will try to draw these lines. As you can see that these lines at point P and at point Q, or other cross section A, P and cross section Q, if you look at, this is the cross section P, this is cross section Q. So at Q, the streamlines are coming closer, while at P, they are more spaced up. This spacing up also is, it is indicating something. So what does it indicate? It's first of all the density of the lines which it is representing, and that shows how fast the liquid is traveling. So as the liquid approaches point Q, it is starting to move faster and the cross section is becoming smaller. But if we speak about point P, relatively the area is larger and lines are more spaced up, so they are basically going to suggest that the liquid is flowing relatively slow. Okay, remember a very important point, guys, that the streamlines do not cross each other. Okay, everyone. So quickly answer a quiz question, and it's actually a free point for everyone. And I've just answered this, so I'm sure that everyone will be able to answer this quickly question in front of you. Do two streamlines, do they cross each other ever? I'm giving you only and only 15 seconds for this. Yes. Do two streamlines, will they ever cross each other? You have to answer in A, B, C, D. Time starts in 3, 2, and 1. Come on, everyone. 3 marks. Okay. Okay. Awesome. Then the time is up. Let's see. Still, you have to like misclick it, huh? Everyone. So I just told you guys that the two streamlines will never cross each other, because the streamlines are suggesting the direction of the flow and the velocity particle. So that's why they will never be intersecting with each other, because otherwise it will be meaningless to talk about the streamlines. Okay. A brief discussion of turbulent flow also, guys. Turbulent flow is basically when the fluid is moving, it basically starts to have intermixing of the fluid layers happening. So when this starts to happen, we say that the fluid becomes turbulent and obviously becomes a relatively more what should I say? I'm not getting the right word to actually talk about it. It's more like tornado kind of situation happening with liquid. And if we speak about from magnitude point of view, it becomes relatively more scary looking comparative to the streamline flow. Okay, so this is how you can actually look at it. How the particles are moving, they're having their zigzag path motion. So the layers are actually mixing together, and the liquid is flowing through this tube. So this is basically how the turbulent flow is going to happen. The particles are rotating also. They are moving forward as well. They are trying to cross each other's path. So this is the kind of situation which happens when we speak about the turbulent flow. Okay, so quickly try to answer this one based upon the same. At high speed, which flow do you think will dominate? Turbulent flow or non-turbulent flow, or maybe turbulent or not, or none of these? What do you think? 30 seconds, and the time starts in 3, 2, and 1. When do you think it will be scary with the high speed or not really? So accordingly, you will answer this one. Okay. Good. Yes. So when the speed of the fluid becomes very high, then the chances of it getting into the turbulent zone of flow are obviously very high. That is where the intermixing of the layers is possible. So more of a common sense and trivial question this was. Now we'll move to the real or the more important discussion for today, and that is equation of continuity and Bernoulli's theorem. So everyone, maybe you guys have done this by yourself, but you may have definitely seen this. That if there is a pipe which is connected to a tap of water and you open up the tap, maybe you're trying to water the plant somewhere. Okay. So when you're watering the plant, when you're showering the water will go to a certain distance only where you're standing from. So what will you do if you want the water to go further, a larger distance? What do? We either press the pipe or we try to cover some part of its mouth. We do that. We either try to cover some part of its mouth or we try to press it. Yes, everyone knows this from their own experience. So in that case, what exactly happens? Definitely the velocity with which the liquid is coming out increases. Do you agree? It increases the velocity by, again, from a very common sense point of view, right? But what we are seeing here, that when we are reducing the area, the velocity with which the liquid is coming out is increasing. Do you agree? So there is some correlation between this area of cross section and the velocity of the liquid. Right, everyone, and that is what is equation of continuity. The correlation between area of cross section of the tube and the velocity with which the liquid is moving forward. Right. So, say if we consider any cross section or any part of maybe uneven tube. I'm saying because we don't want just the area of cross section to remain same. We want its area of cross section to be different at different points. So this is maybe a situation where when the liquid enters from say point 1 and it starts coming out from point 2 or area 2. So area A1 is smaller one and area A2 is the bigger one. So definitely V1 is going to be more than the velocity V2. Okay, everyone. So when we speak about equation of continuity, we first of all do this only for ideal fluids. Okay, this is written for ideal fluids. And when we are writing this for ideal fluids, the fluid when it is traveling, it should completely have started coming out now. It should not only be there to enter, it has also started coming out. So liquid started entering and it has started coming out. That is the means completely the pipe is filled with the fluid. There is no air gap in between. Continuously it is filled with the liquid. Liquid is incompressible. Liquid is ideal. And now, if I consider for a very small duration of time t, because the area of cross section is not same. So for a small duration of time t, when a layer of liquid starts moving, say from point P to point Q. Okay, everyone. So when the layer of liquid starts moving from point P to point Q, its velocity almost remains the constant. Area of cross section almost remains the constant. And in this case, the length which is traveled by the liquid is velocity into time. Okay, guys. Do we agree? The velocity into time is going to be same. Or I'm not saying, but we can say that velocity into time is going to be the length which is traveled by the layer which entered from point P and moved a very small amount of distance, that is Q. So there is some volume of the liquid which has got enclosed in this region. Okay, everyone. Similarly, when the liquid has reached say point R to S, From R to S also to travel, it takes the same time t, but obviously its velocity has changed as the area of cross section is different. So it travels some distance L dash or L2, you can say it is. And that L2 distance it travels, it comes out to be V2 into t. So if this is L1, this is V1 into t. This is L2, that is V2 into t. Okay, everyone. So we understand there is some cylindrical portion or a disc kind of portion which has been formed here. Okay, everyone. In that, we know that this length is L, the area of cross section is A, so the volume is going to be A into L. Why do we need this volume? I'll speak about that. That what equation of continuity talks about is, why it is called equation of continuity is because first of all it assumes or it works only for streamline flow, and it says that if the liquid is incompressible and it is moving in a streamline manner, then the amount of liquid which is entering, say, from point 1 at a given time, at the same duration, the same amount of liquid will come out, so that the amount of liquid inside this region, say this region is X, in this region the amount of liquid which is always there, it remains the same. That is only possible when, say, 1 liter or maybe 1 kg of water is entering every second and 1 kg of water is entering also, exiting the tube as well. Why it is important to call this liquid to be incompressible, or other way around, that when this will happen, then only the liquid will stay incompressible. Why? Say if more liquid is coming in and less liquid is able to go out, then the liquid is forced inside the volume to compress further, and our liquid cannot compress. Its density cannot change because it is an ideal liquid. Okay, so it is valid for an ideal fluid. Okay, so what we are saying, what is the equation of continuity? It says that the amount of mass entering per unit time in a given tube is going to be equal to the amount of mass that is exiting in the same time from that tube. Okay. Okay, that means dm by dt, mass flow rate, is what we call it. Mass flow rate, we call it dm by dt, and that is equal from the portion where it is entering and the portion from where it is exiting. Okay, now how do we write this mass value? We can write the value of mass as density into volume, and that is where things are going to get interesting, because volume we are going to put from here, and how we are going to write this length is also very interesting, because we have just found the length as velocity into time. So v into t. Okay, so a into v into t is going to be the volume. We'll place it here, and this divided by time is what we are going to write as the mass flow rate. So have a look at this guys now. So dm by dt is what we are trying to write. So I told you that guys that what we are writing here is mass upon time, mass entering per unit time. So we can say that the density of the liquid multiplied by the volume is basically the amount of mass which is entering. Okay, so actually I should be dividing it by the value of time so that we get the value of mass flow rate. But here, assuming that the time is 1 second in which this is happening, so just have a look at what I'm trying to write here. When I'm trying to write the mass, I'm saying it is density into volume. This is density. Volume is going to be area of cross section into the length. And how we are writing the length? We are writing it as velocity into time. And that is why, look at this. It is density of the liquid. Okay, and it is going to be same throughout the liquid itself. So rho 1 and rho 2 are definitely going to be the same density. So you will definitely see them getting cancelled. Same time in which liquid is entering, I'm talking about the same time in which the amount of liquid which is going to come out. So T also gets cancelled. So what you're left with is basically V1 into A1 equal to V1 into V2 into A2. So A1 V1 equal to A2 V2, where V is basically the velocity. Okay, this is small v, not the volume. Remember that. Okay, everyone. What we are writing here as V1 and V2 are the velocities with which your liquid is entering and exiting. Okay, so A1 V1 equal to A2 V2. This is called as the volume flow rate. Why it is called volume flow rate? If you will check the dimensions of A into V, area is meter square, velocity is meter per second, so the unit becomes meter cube per second. So it is volume entering per unit time is equal to volume coming out per unit time, and this is coming from the mass flow rate being also the same. So if the density is same amount of mass entering per unit time is equal to same amount of mass exiting per unit time, that means same amount of volume entering per unit time is going to be the same amount of volume going out per unit time. Okay, everyone understands this? Quickly, बहुत simple equation है. You have to keep this in mind. A1 V1 equal to A2 V2. Okay, is that clear to everyone? Sure. Yes, Tushar. Bolo. This is not applicable in turbulent flow. Yeah. Equation of continuity. Yes. How does it work, Hasan? Some of the liquid stays behind, Hasan. I'm not getting your point. So if I put my hand in front of the mouth of the pipe, say half I cover it. Okay. So maybe here the area was A and the velocity was V, right? But here what will happen? So when the pipe was not closed, with the same velocity in the same area, the water was coming out. So far I think the things are clear. Now, if I'm going to cover the half of this area, then the area will become A by 2. Have you noticed that if you do that, the water also is going to cover more distance now? That means what? Its velocity is going to increase. So its velocity will now become 2v. So that the product of A into V will remain the same. So earlier at point 1, it was A into V. At point 2, you will write it as A by 2 into 2v. Is it still the same value? That's how the velocity will change as the area will change. Okay. Yeah. So we study it only for streamline flow. It is defined for streamline flow. Okay, everybody. Because in turbulent flow, the velocity is something which is very, it is not very easy to talk about the velocity of the particles at a given point when the liquid is flowing in a turbulent manner. That's why. Okay. Sure, everyone. Let's see a few questions based upon the same. The question which has come in JEE Main 2020. It says that an ideal fluid flows through a laminar flow, or you can say the streamline flow. Ideal fluid will always have a laminar flow, is what we assume, through a pipe of non-uniform diameter, obviously. So the maximum and the minimum diameters of the pipes are given to us 6.4 and 4.8. Obviously, where it is 6.4, the area is more, and if area is more, definitely there the velocity is less, right? And the second one is 4.8 centimeter. The ratio of minimum to maximum velocity of the fluid in this pipe is going to be how much? Okay, guys, I want you people to first tell me which are the two options that you can eliminate without even solving the question. Which two options can we eliminate? I'm not asking you the answer. Elimination. We can eliminate two options here. Read the last line of the question first. Those who are still not getting the point. Those who are clueless, please read the last line of the question. It says the ratio of minimum to maximum velocity of the fluid in the pipe. Why minimum to maximum? Can I say this ratio will be less than 1 only? If there is something minimum divided by something maximum of the same quantity, definitely that ratio will be less than 1. Look at option A and D. The ratio is more than 1. Getting? So it cannot be the answer straight away. We can directly rule out that these options not possible because these are greater than 1. right? So now we'll see religiously how we solve this question. So what easy question, everyone. So simply equation of continuity will say that A1 V1 will be equal to A2 V2. Say V1 is minimum and V2 is maximum. So definitely the value of A1 is more, A2 is less. So where area is more, velocity is less. Inverse proportionality, as simple as that. So you simply have to not even think much about it. Area is going to be pi r square, or we can say pi into d by 2 ka square. So simply diameter ka square karna hai. So we get it as 4.8, the lower area divided by, or the minimum area to the maximum area. So simply 48 by 64, or you can say it is 3 by 4 ka square. So value comes out to be 9 by 16. As easy and as straightforward, as simple as that. Okay, everyone? Clear? Nice. Sure. A question for all of you guys to try now. This one, this says that maybe just imagine it to be like a river. In that river, the liquid is flowing, maybe an ideal fluid is flowing and flowing in a streamline manner. The area of cross section of this part, or you can take it as a tube also. So tube is getting split into two, or a pipeline is there. So this portion of the pipeline has area 10 centimeters square, velocity of the liquid is 5 meters per second. When it reaches these two, or when it reaches junctions, maybe J, so it splits into two streams. One of the streams is going towards this part where area is 3, velocity is 12. The other is area 5, but velocity is not known. So all you have to think of is the amount of volume per unit time which is entering from 1, this is 2 and this is 3, should be equal to amount of volume coming out per unit time from 2 plus volume per unit time from 3, because the amount which is entering from 1 and it is exiting from two outlets. Those two outlets are sharing the amount of volume which was entering from point 1. Okay, so try to think from these lines. I'm going to give you guys 2 minutes and the time starts in 3, 2 and 1. Uh, 25 seconds more, everyone. Okay, and last 5 seconds, everyone. And the time is up. Let's see. Okay, so guys, this was actually not that challenging if you approach in the manner that I told you people. So if we say that the amount of mass entering per unit time will be equal to mass exiting per unit time, we can say the amount of volume entering per unit time will also be equal to amount of volume exiting per unit time. So A1 V1 is the volume entering per unit time, and A2 V2 plus A3 V3 is the amount of volume that is exiting per unit time. So area of cross section is 10 into 10 to the power minus 4 to convert it into meter square, multiplied by the velocity, that is 5. Then the volume which is exiting from section 2 is area 3 into 10 to the power minus 4, velocity 12. And the last one, area is known, 5 into 10 to the power minus 4, the velocity is not known. So if you simplify this, simply you can see that 10 to the power minus 4 gets cancelled. So this becomes 50 minus, this is how much? 36. So 24 by 5, when we simplify this, value comes out to be 2.8 meters per second. Okay, so guys, you will be very lucky if you get questions in your JEE examination from fluid mechanics and that too, this thing, the equation of continuity, because they very rarely will give you a question which is straight away directly based upon the equation of continuity as this one. So if you're lucky, you'll get a question which is directly based on A1 V1 equal to A2 V2. So usually that doesn't happen. It's not the case, because now we are studying the Bernoulli's theorem. Will be studying this, where the equation of continuity is inherently always applied. While solving the questions also, most of the time we will require to use equation of continuity as well. So 90% of the chances if you're getting a question from fluid dynamics and the question is coming, then the question is not going to be only from equation of continuity, it's going to be from Bernoulli's theorem, because it tests two concepts, equation of continuity and Bernoulli's theorem itself. Now what exactly this guy Bernoulli, who this guy was, he was a Swiss scientist and a mathematician. They were extremely into science, obviously. So this guy is a Swiss scientist, he used to be, and his surname is Bernoulli. That's why the theorem which he'll give will be known as Bernoulli's theorem or Bernoulli's equation. And Bernoulli's theorem is actually law of conservation of energy, or we can say work energy theorem in liquids when they are flowing. It is as simple as that. Okay, means this is what we'll be speaking about, that energy of the liquid when it is entering inside a tube plus the amount of work which is done by the external factor or external force is going to become equal to the amount of energy which is coming out. Or simply, whenever you're going to work on anything, the work done is going to change the amount of energy that is possessed by that thing. Okay, so this is basically it is based upon. So let's see how it works. First of all, Bernoulli's equation will be spoken with respect to flow of fluids. So consider this situation a typical diagram to explain derivation of Bernoulli's principle. Though the derivation is not important, let me tell you that also, but I'll still tell you how it is approached or how that final expression comes. It says that if we consider two cross sections, cross section 1 and cross section 2, with obviously different areas of cross section, just to demonstrate it better. So when the liquid is entering through cross section 1, its velocity is v1. When it is coming out, its velocity is v2. Also, the end 1 is at a height h1 from the ground. That would be 0 also. And the height of the other one is h2, depending upon the situation. That will be more than h2, more than h1, or it will be equal to h1. We'll see those situations also. Also, the pressure with which maybe the liquid is, or the pressure which is experienced by the liquid at point 1 is p1. The pressure which is experienced by the liquid at point 2 is p2. Okay. So have a look at this diagram properly, guys. Here, area is a1, velocity is v1, pressure is p1, and the height is h1. Okay. Similarly, here the area is a2, pressure is p2, velocity is v2, and the height is h2. Okay, this d1 and d2 are only telling you amount of length which is traveled by the liquid in same time in cross section 1 and cross section 2. So what we are going to do, we are going to try to write the energy in the beginning, the energy in the exiting time, and the amount of work which is done by the external force, which is basically the pressure. So when we try to write down the work done by the external force on the fluid, so what is that external force? It is basically the force applied by the liquid pressure itself, okay, or maybe the atmospheric pressure from outside. So maybe you can think of it this way, that when we have to take water from the ground floor to the topmost floor, maybe we have water tanks at the top of our houses in our buildings. How do you think that the water rises itself? It will never rise by itself. You will require a pump which will create a pressure, which will apply a force, because of which the liquid will rise up. Okay, so whatever be that pressure P1 and P2, so the external force is going to be nothing but force acting here is F1, making the liquid travel a distance d1. Similarly here, the force which is acting is going to be F2, which is making the liquid travel a distance d2. Okay, what is this force? It is nothing but pressure into area. So P1 A1 into d1 and P2 A2 into d2. That's basically your force. So from here, we can say that the overall work done A1 D1 is nothing but the volume V1, and A2 D2 is nothing but the volume D2. That's basically the volume of this small cylindrical portion, you can say. So this is D, area is A, so the volume is A into D, just as we saw in the equation of continuity as well. Okay guys, so we have got the value of the work which is done by the external force. That comes out to be P1 minus P2 into V, assuming that P1 is greater than P2 because the liquid is flowing from 1 to 2. That's why. So this comes out to be the work done by the external agent. Let's try to write down the amount of energy which the liquid has, or this chunk of liquid has, which has traveled a distance D1, this volume, this small cylindrical volume that we are talking here about. Let's talk about the energy which it possesses. So obviously it will have potential energy and kinetic energy. We are studying mechanics, so two types of energy only. So when we write the value of potential energy, it is mass into G into H, right? M into G into H is how we write the potential energy. Mass I can write as density into volume into G into H. So you can see that it is rho into G into V into H1. This V is the volume. Okay, everyone. Sorry, this V is, just a minute. Rho into V. This is volume, correct? Okay, everyone. So rho into G into V into H1 is basically mgh. Similarly, as we know, mass is nothing but density into volume. So I want to write down kinetic energy. So it will be half mv square. So the energy, kinetic energy becomes rho into V, that is its mass, into the velocity ka square, which the liquid has when it is entering from cross section to number 1. Okay, everyone. So this is mass into G into H, that is H1, and half into M into V square. So we have half mv square and mgh written over here. I hope everyone understands this. Potential energy at 1 and kinetic energy at 1. Okay, cool. Similarly, we will write the same at cross section 2 also, which is going to be very similar. You can see that again, rho into G into V into H2. At what height the liquid has reached, accordingly, that chunk of liquid, the chunk of liquid at 2, its amount of mass we have already written, it is rho into V into G into H2 will make it mgh, and similarly half into mv square. But the velocity has changed to V2, that's why half mv2 square it becomes. So now we have the three equations or three parts of the equation. This is part 1, part 2, and part 3. We'll put all of them in equation number 1 now. Right, so half rho V H1 plus half rho V V1 square. So this is your potential energy, kinetic energy at 1. This was the work done. This is potential energy at 2. This is kinetic energy at 2. So something will definitely get cancelled here. Let's try to cancel those things. I see that volume wala part is getting cancelled throughout. So the equation looks like P1 minus P2, and if I take P2 also on the other side, I have P1, P2 was on the right hand side, rho into G into H1 plus half into rho into V1 square, and on the right hand side also the equation has similar terms. It's not equal, all the terms are not equal, their summation is equal to the left hand side terms. So P2 plus rho G H2 plus half rho V2 square. So basically what Bernoulli's theorem or Bernoulli's equation tells that the value of pressure at a given point plus rho GH at that point plus half rho V square at that point will be equal to the pressure plus rho GH plus half rho V square at some other point also. So this is written say for point 1 and this is written for point 2. So when we are writing these two at different points, if the liquid is flowing in a streamlined manner, you can write these values of pressure plus half rho GH plus half rho V square. These values can be written for any 2 points and equated because the overall energy of the liquid will always remain the same. This is what is the law of conservation of energy. How do we pronounce it, by the way? When we write this, we can say that pressure into volume is work, or it has the dimensions of energy, right? So we can say if we have divided this entire equation by volume, so when we write at this that work or energy is pressure into volume, we can say that work upon volume is nothing but pressure. So we are going to say that this is pressure energy. When we can actually just call it pressure also, but I'm just trying to make sense in terms of the energy part of it. So we can look at P as pressure energy per unit volume. Okay, rho GH is potential energy per unit volume. Why it is per unit volume? Because if you will find out the dimensions of it, you will get the dimensions as joule per meter cube. Similarly, half rho V square, you know that density is mass per unit volume. So this is basically kg per meter cube already, and multiplied by velocity, that is meter per second square, that value meter square per second square. When you simplify this, it comes out to be kg meter per second square. Okay, everyone, getting the point here? So overall, what you have to remember, even if you don't remember the name of the terms, the value of the pressure at a given point, the value of rho GH at that point, plus the value of half rho V square at that point, that value will always remain a constant. Okay. So according to Bernoulli's principle, if ideal fluid moves along a streamline, then the sum of pressure plus kinetic energy per unit volume plus potential energy per unit volume will always remain a constant. Please note down this equation if you have not. This is what we call as the Bernoulli's equation. Very important point we have reached in the fluid mechanics today. Okay. Okay, everyone, noted? Okay, just defining the properties that we have taken into account for an ideal fluid. We have been speaking about them for a long time. That an ideal fluid is going to be non-viscous. It will not have any viscosity. It will not have any variation in its density. It is incompressible because if it gets compressed or expanded in the same mass, now the volume is different, then the liquid will have different density. In that case, we can say it has become compressible. So we don't want the liquid to be compressible. That's what we consider it to be an ideal fluid. Secondly, or thirdly, it will have a streamlined flow. And last one, it doesn't show rotational effect. By rotational effect, we mean that it will not create any kind of turbulence. Okay, tornado kind of effect will never be shown by an ideal fluid. That's the kind of definition of the properties which an ideal fluid must offer. Okay, everybody understands this? The derivation is not important. Repeating once again, the derivation is not important, not even from your school examinations point of view, but this final expression is very important. Okay. So let's have a look at some examples and questions for this one. Okay, guys. Yes. Theory is done. I think theory for the day is done. Let's move on to the questions for today. Okay. Yeah. So everyone, the question says the water from a water tap, it emerges vertically downward. Okay. So you have a tap from which the water is coming down. Yeah. Have you guys ever noticed that when the water comes down from a tap, as it moves down, its stream becomes thinner and thinner and thinner? Do you guys know that? You guys have noticed it, right? Exactly. Have you guys ever seen the people or other the chai walas when they try to make tea, they will always take the container and they will transfer tea from one to another like this, right? And we say that they are showing off. We say that they are showing off because they will like deliberately take the one of the the one where the liquid is going to come from. They will take it like on the top, and then from there they will drop it, right? they actually do not know this, but they are applying Bernoulli's theorem. They do not know it, but they are applying Bernoulli's theorem. Yes, this, as the liquid falls more and more from a tap, or as it is made to fall in a stream, the stream becoming thinner is the application of Bernoulli's principle, or Bernoulli's theorem. But obviously, a chai wala doesn't know Bernoulli. He doesn't even care who Bernoulli is and what Bernoulli's theorem is. He definitely is showing off, but he doesn't know. We know that it is basically the Bernoulli's principle. So next time when we try to put liquid from bigger container to a smaller one, if you are able to manage it, try to drop it from some height without taking my name. Okay, don't put it on me if the chai spills off. So when you are putting that, you're trying to fill the container glass usually. If it has smaller mouth, you want a smaller stream to enter inside, right? If it has smaller mouth, so you want a smaller stream to enter inside, and for that to happen, you have to make the liquid drop from a relatively higher height. That's why. Okay. Okay. Bernoulli. Awesome. Your Indian version of Bernoulli for us then. When you go to college, people will actually call you Bernoulli. Yes. Our PM is fluid mechanics expert. Absolutely. Chalo, everyone. Let's move on to the question. Question is actually asking us to find out the cross-section area of the stream when it reaches here. So maybe here the area of cross-section is A1 and here the area of cross-section is A2, and A1 and A2 will not be same. The reason is also very simple, by the way. Here the velocity of the stream is going to be V1 and here the velocity of the stream will definitely be more. As the liquid falls, its velocity will increase. But though we want to directly apply A1 V1 equal to A2 V2, we don't directly get to apply this. Why? Because we do not know both of these values. We do not know both the values. We don't even know the value of area which we want to find out A2. We don't even know the value of velocity V2. To find out V2, we will require Bernoulli's theorem. Okay, so this is the kind of question that you can expect mostly in exams like JEE. So water from a tap emerges vertically downward with an initial speed of 1 meter per second. So V1 value is given 1 meter per second, and area of cross section is also given 10 to the power minus 4 meter square or 1 centimeter square. You can say that. Okay, everyone. And the liquid is assumed to be flowing streamline. Find out the area of cross section. As simple as that. Okay, so let me just try to give you an idea by looking at this beautiful diagram that I've drawn. Okay, so the image was always there, but then I have written things here. So this is point number 1. This is point number 2. So point number 2, where I'm interested in finding the area, that level I'm considering as height equal to 0 because I want to apply Bernoulli's theorem, right? So I need to write the potential energy. So this is height h equal to 0. The tap is at a height 0.15 meters above. Their area is also known 10 to the power minus 4. The velocity is also known, that is 1 meter per second square. Sorry, 1 meter per second. So everyone, at point number 1, the liquid has started coming out. So it is basically atmospheric pressure which it is experiencing. And at 2 also, it is only atmospheric pressure which is going to exert at 2 the external pressure that we are talking about. So when we try to write P plus rho g h plus half rho v square, so have a look at this. The pressure on both the points, point number 1 and point number 2. This is point number 1 and point number 2. So point number 2, I'm writing it first. Okay, this is written for 2. This is written for 1. The right side. So pressure is P naught. Height is 0. So h rho g becomes 0, and velocity is v2. So I'll write half rho v2 square. Okay, but let's write it for 1. The pressure is P naught. The velocity is half rho v1 square, but rho gh will not be 0 now. Why? Because it has some height which is non-zero, and that is 0.15. Simple. So P naught gets cancelled. Then you can see that rho also gets cancelled after that. So left hand side, right hand side, if you multiply by 2, you have v2 square equal to v1 square plus 2gh, or v2 equal to v1 square plus 2gh in under root. Okay, are we all clear so far with the explanation here, everyone? Okay. Does it make sense to all of you? Correct? Yeah. Don't call it third equation of motion. It has turned out to look like that, but it is not third equation of motion. It will not always be this way. Okay. So now people will put the value of v1. We know that. We know the value of g. We know the value of h. We'll find out v2. And once we get the value of v2, we will put it here and we'll calculate the value of a2 as a1 v1 upon v2. Okay. So a1 v1 equal to v2 we will be applying. So they're directly solving v2 here only. So a1 ka value 1 centimeter square. You can write it as 10 to the power minus 4 meter square also. The velocity is 1 meter per second. A2 is unknown, and this we are writing as v1 square plus 2gh in under root. Okay, so v1 is 1, 2 into g into h. H is 0.15 meters. Simplifying that, so it overall comes out to be 2. Okay, you can see that this is 1 plus 3, that is root 4. Root 4 is 2, so the value comes out to be 0.5 into 10 to the power minus 4 or 5 into 10 to the power minus 5 meters square. Okay, so the answer is option B here. Everyone understands? In the chat box. Good, great, nice. Okay, so does P naught change with height? Yeah, P naught is actually atmospheric pressure. So atmospheric pressure value is going to remain same at this height gap. That's why. So P naught is atmospheric pressure. That's why. So it's remaining same. Okay. First slide of the solution. Given pressure is constant. Okay, Kushi, do you understand? Yeah, atmospheric pressure at this height and atmospheric pressure at this height is almost the same, right? Atmospheric pressure will also change, but like if you're living in Mumbai and then you go to Nainital or if you go to Shimla, that is where atmospheric pressure difference comes into picture. But as long as I'm on 4th floor, I'm on 3rd floor, I'm on 1st floor, everywhere the pressure is almost the same, right? Atmospheric pressure, right? Atmospheric pressure on hill stations is less. That's why people have difficulty in breathing. You know? The overall concentration of gases is different. Okay, chalo, everyone, next question. This one again is based upon Bernoulli's theorem and equation of continuity. It says that an ideal liquid, maybe water, water is not ideal liquid, but they are considering an ideal liquid like water flowing through a tube of non-uniform cross-section where point A and point B have different areas of cross-section, 40 and 20 centimeter square. If the pressure difference between A and B is 700 Newton per meter square, then the volume flow rate will be how much? How much is the volume flow rate in the pipe, which is going to remain the same? Okay, volume flow rate, amount of volume entering and amount of volume coming out at any point is going to remain the same. Okay, so we have to find that value. A into B is we want to find out. So if we get the value of V1 or VA, we will write it as area into volume velocity here. And if we get the velocity VB, we can write the area A2 or AB with VB. Okay. So everyone, if we apply equation of continuity here, we can get the relation between the velocities directly. So VA into area of A will be equal to VB into area of B. So area of A is double the area of B. So we can say that velocity at B will be double the velocity at A because smaller be the area, faster be the movement. Now let's apply Bernoulli's theorem at A and B. So pressure at A, by the way, they are at the same horizontal level. That means if I want to consider their height, all the points or both the points are at the same horizontal level. So PA plus half rho VA square plus rho GH. If I want to write down rho GH, we can write, but hoga kya? It is going to get cancelled because both the points A and B are at the same horizontal level. So PA plus half rho VA square plus PB plus half rho VB square, right? And PA minus PB is given to us, right? So the pressure difference between A and B is given to us here. Okay, so this value is given to us as 7,000. Half into density, because they have said it to be like water, so that's why density is 1,000 into VB square minus VA, which we can say is VB by 2, so VB square by 4. So this comes out to be 700 equal to 500 into 3 by 4 VB square, right? So that is what it is. Delta P equal to 500 into 3 by 4 VB square. Okay. So from here VB square is known, so VB or rather VB square is unknown, so we can find that out as 700 into 4 by 1500 comes out to be under root of 28 by 15. So very calculated question this was. So the final value of volume flow rate is velocity of B multiplied by area of cross section of B. So velocity is under root of 28 by 15 and multiplied by 20 into 100. This gives me the value of volume flow rate. Okay, everyone. 20 is centimeter square. That's why. Okay, area is 20 centimeter square into the velocity under root of 28 by 15. Okay, so they have basically done what? They're writing it as 28 by 15 in under root into 100 centimeter per second. So this 100 that you are saying is coming from there. And area, they're writing it in the form of centimeter square only. So that's why this becoming centimeter, this is centimeter square. So both of them multiply to give you the value as centimeter cube. Okay. So the answer comes out to be 2732.5 centimeters cube per second, or we can nearly put this value as per the options 2720, the nearest option. Okay. Okay. Low Utkarsh. Is it understood to everyone? Lengthy but doable question, definitely. It was actually a quiz question, but I knew that I cannot give you sufficient time to solve this. 2 minutes, it's not possible to be done. Okay. Yes. So, yes. Last question of the day, in fact. Yes. Yes, next is the question, quiz question, and I will create that question as a quiz for all of you guys. Okay. And here is the question. You guys read it. Meanwhile, I'll create the quiz. It says that a fluid is flowing through a horizontal pipe of variable cross section with speed V at the point where the pressure is P. At the same horizontal level, there's another point where pressure is P by 2 and the speed becomes capital V. So there's a difference between small v and capital V. Okay, don't take them as the same velocity. Question is asking us that if the density of the fluid is rho and the flow is streamlined, then find the value of capital V. What will be the value of capital V where the pressure is P by 2? Okay, so maybe this is how the variable cross section is. Here pressure is, okay, first let's do this. Maybe like this. So here maybe pressure is P, velocity is V. Here pressure is P by 2, velocity becomes capital V. This is what you have to find out. Okay, you will require Bernoulli's theorem, absolutely, to do this. Giving you guys complete 2 minutes, and your time starts in 3, 2, and 1. Forty-five seconds more, everyone. Okay, and the time is up. Okay. So it was actually a much more easier question than the previous one. Answer is option B, and let's see how it is easy. So here, because the area is less, so the velocity will be more and pressure will be more. So here pressure is P, velocity is V, and here pressure is half P by 2 and velocity is V, capital V. And both of them are at the same horizontal level, so that's why their rho GH value will get cancelled on both the sides. That means if you want to write rho GH, you can, but eventually that will cancel. Okay, so pressure at this point is P, velocity is V, so P plus half rho V square equal to P by 2 plus half rho capital V square. So I can take this P over here and write one more step. It will become P by 2 plus half rho small v square equal to half rho capital V square. So half also gets cancelled, and we can say that P by rho plus V square equal to capital V square. So that's why the final answer will be P by rho plus V square and under root. That's the answer. Okay. Okay, everyone. So surprisingly, we have covered like 63 slides today, though it had like 5-6 slides of the Vedanta results, but we have done a good job. Okay. So congratulations to you guys who are there in the leaderboard. Sanidhya, Udit, Harsh, Aditya, Nanda, Nishchal, Ananya, Gauri, Akshat, Daksh, Pradnya, Paridhi, Jebin, Jessica, and Ansh. Congratulations, everyone. Okay, so officially the slides are done. Okay, and before I open up the chat, obviously you guys don't leave the class before this, so let me give you this. And this as well. Okay, so switching on the chat. वेदांतु की ब्रांडिंग वाला बैंजो, वो भी कुछ है। इट्स अ ड्रम, इज इट कॉल्ड बैंजो? ओके sir, at any point one there will not be any pressure by default in the tap image question. Irfan, hello? Yes Irfan, yes Irfan, tell me. Yes, definitely it is created. After it has come out of the tap, then the stream will not have the effect of that pressure as long as it was moving in this part, as long as it was moving in this part, which is basically the tap wala part. It was inside the pipe. Till that time the pressure which was created from inside was the pressure, right? But after it has started coming out, then it has no effect of the tap, right? Then it is under the influence of atmospheric pressure. Okay, cool. Yes. Sir, is Venturi effect and equation of continuity same? No, Harshan. That is what I said. Some part of Bernoulli's theorem we will be covering in the next class. So we will speak about something called as Venturi meter. Venturi meter or Venturi effect is basically a subset of the Bernoulli's theorem only. Okay. Sir, mass negative भी हो सकता है क्या? नहीं यार, mass क्यों negative होगा? Mass negative नहीं होता. Okay. Harshad, your microphone is not working. So please show next problem का answer. You mean to say this one? Sir, there is negative mass. अरे भाई किस बारे में बात करना चाह रहे हो? आदिश. Mass can be variable, but mass cannot be negative. Okay. So your discussion on chem versus physics with Mohit sir was very funny. हाँ अर्शद बोलो. ये वाला हाँ, उससे पहले बर्नौली का कोई क्वेश्चन नहीं है, ये पहला क्वेश्चन है बर्नौली का. कौन सा सवाल भाई? हाँ वो पहला ही सवाल है, ये वाला है. यहाँ पे 2 से मल्टीप्लाई किया है, यहाँ इक्वेशन में डिनोमिनेटर में 2 था ना. ठीक है. तो क्या? अच्छा ठीक है. ओके, थैंक यू अर्शद, थैंक यू, बाय बाय. अंश, योर माइक्रोफोन इज नॉट वर्किंग. थैंक यू वेदिका. प्रियांशु, वेट फॉर सम टाइम. यस अमन. यस बच्चा. आई एम गुड यार, जस्ट टायर्ड, बाकी आई एम गुड. चलो क्लास से बोलो ना. हाँ 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 याद है मुझे. भाई माइंड फोर्स स्टोन पे किसने लगाया? लिक्विड ने लगाया, राइट? और तुम्हें ये भी मालूम है लॉज ऑफ मोशन से कि फोर्स कभी भी सिंगल एग्जिस्ट नहीं करता लाइफ में. फोर्स हमेशा एज अ पेयर एग्जिस्ट करता है, लेकिन वो पेयर हमेशा सेम बॉडी में नहीं लगता. तो अगर लिक्विड ने स्टोन पे फोर्स लगा दिया, whatever that force be, whatever be that force, कोई भी फोर्स हो सकता है, कंजर्वेटिव नॉन कंजर्वेटिव, बी इट कांटेक्ट फोर्स, बी इट नॉन कांटेक्ट फोर्स, डजंट इवन मैटर. कोई सी भी कैटेगरी का फोर्स हो, लेकिन अगर फोर्स लग रहा है किसी एक बॉडी पे दूसरे की वजह से, और उनका कोई भी स्टेट हो, जैसे स्टोन तो सॉलिड है, लिक्विड की स्टेट अलग है, तो भी इफ द फोर्स इज अप्लाइड बाय लिक्विड ऑन द स्टोन, देन द लिक्विड विल आल्सो एक्सपीरियंस अ फोर्स इन द डाउनवर्ड डायरेक्शन और अपोजिट डायरेक्शन बिकॉज़ ऑफ द स्टोन, एंड दैट फोर्स इज बायन फोर्स. हर केस में होगा, बिल्कुल हर बार होगा. हाँ, तो यहाँ पे मशीन रखी हुई थी. हाँ, तो उसकी रीडिंग आएगी भाई, डब्ल्यू अगर वेट है, मुझे याद नहीं उस क्वेश्चन में डब्ल्यू दिया था क्या, लिक्विड का वेट डब्ल्यू है, जो भी डाउनवर्ड लगा है, उसके साथ एफ बी ऐड हो गया, तो रीडिंग क्या होगी? डब्ल्यू प्लस एफ बी. क्या है कंफ्यूजन? अरे स्टोन का वेट थोड़ी ना ले रहे हैं, स्टोन थोड़ी वेइंग मशीन के ऊपर है. वेइंग मशीन ओनली रीड्स द फोर्स बाय व्हिच इट्स सरफेस इज प्रेस्ड. ये बताया मैंने लिफ्ट वाले क्वेश्चंस में, जब हम सूडो फोर्स डिस्कस करते थे तब भी बताया था कि वेइंग मशीन को नहीं मालूम कि वो तुम्हारा वेट है या नहीं है. वेइंग मशीन को बस ये मालूम है कि उसकी सरफेस को तुम कितना जोर से प्रेस कर रहे हो. पहले वेइंग मशीन की सरफेस पे जो फोर्स था प्रेस करने वाला, वो सिर्फ लिक्विड का वेट था, लिक्विड प्लस कंटेनर बोलो, ठीक है. लेकिन अब लिक्विड प्लस कंटेनर पे एक और डाउनवर्ड फोर्स आ गया, एंड दैट फोर्स इज बेसिकली एफबी. दैट्स व्हाई. समझे? अगर यहाँ स्प्रिंग बैलेंस लगा दूं ना, यहाँ जो एक क्वेश्चन में किया भी था हमने, अब स्प्रिंग बैलेंस की रीडिंग जो है वो, अगर मान लो इसका वेट डब्ल्यू डैश है, तो उसकी रीडिंग ऑफ स्प्रिंग बैलेंस की हो जाएगी डब्ल्यू डैश माइनस फोर्स. दिस इज द स्प्रिंग बैलेंस. आया समझ में? बर्नौलीज. हाँ ये फाइनल होना चाहिए. करेक्ट. कर दिया करेक्शन. ठीक है. ओके, टेक केयर, बाय बाय. So weight of the container was negligible. You can consider that to be negligible, or that is added to the weight of the liquid. Sir, why which month 12 class course will be finished? अरे 11 तो पूरी कर ली मेरे भाई, 12th पे जा रहा है. Yes, good evening बच्चा. हाँ, density of the liquid which is flowing. The density of the liquid which is flowing, it is in the question. In the question. Yeah, symbols might look sometimes weird, but that means the same thing. Okay, we need the symbol just to give you a separate clarification on that. Ignore that different looking symbols of row. While typing, they have like different possible types of fonts, so that sometimes happens. Okay. Yeah. Okay. Sir, is laminar flow ideal case? No. Ideal fluid flows in laminar manner, but that does not mean real fluid does not obey laminar flow. Real liquid can also have laminar. Okay. Sir, will we get any traces of Archimedes principle in the question? Which question, Aryan? So these things which is for ideal fluid, when then why are they used in real life? That pipe and tap. Because ये मैं पहले भी आंसर कर चुका हूँ. Why do we study ideal things? We study ideal things so that as engineers, as people who are related to science, we can try to bring things which are real closer to ideal. So if you understand ideal behavior, then only we can try to improve on the real behavior. Okay. Hi Harshita. So second last question में P में P18 क्यों लिया था? Second last question में P में P18. I think third last question की बात कर रहा है. ये वाली की बात कर रहे हो? अमन? ये बोल रहे हो ना अमन? हाँ तो लिक्विड बाहर आ गया तो अब हवा का प्रेशर लगेगा ना, एटमॉस्फेरिक प्रेशर लगेगा उसके ऊपर. That's why. Because it is correct, Arshit. Because now it is in open. Sir, will we get any traces of Archimedes in the question of these chapters? भाई बात कर ले यार. Straightforwardly ask me what you want to ask. We have been solving questions which are from Archimedes principle. Buoyancy is the concept of Archimedes principle only. Buoyancy that we study, buoyant force, it's the concept based on Archimedes principle. So definitely we do solve questions and we have questions from previous year from that. Okay? Yeah. Okay. So initially this year I was with green t-shirt. Coaching. But then online was not much favorable to me and I left, but my friend continued that and now they're having offline classes on this one. Due to this, sometimes I feel very bad and sometimes I feel that was my wrong decision. How to overcome this feeling as per you? बात कर ले यार, तू भी बात कर ले. Yes, Adik. I can't read and make sense to things like that. Tell the name, doesn't matter. They are now starting offline, right? You want to go offline? Try कर लो offline भी पढ़ लो. Once your subscription comes to an end, you join Alan also. नहीं? Experience करे बिना मैं कैसे बोल सकता हूँ? I am a person who has experienced something. You go, you experience there, and if you find that this is not extraordinarily different, then you decide based upon how offline is helping you more or online is helping you more. Accordingly, take a decision. Right? Other teachers will obviously tell you that you have to try things first and accordingly take a call based upon your own experience, your own judgment. Without that, this confusion cannot be removed only by me or anyone else speaking to you that online is better, online is better, online is better. I'm not saying offline is not better. Offline is also good. There are pros and cons of both. You have to judge whether you are able to prepare without affecting your own performance in any one of these. You continue with that. You know? Cool. Okay. So will there be any pressure from the pipe on the fluid? Pipe doesn't apply any pressure here. अगर pipe pressure apply कर देता तो पानी अपने आप ऊपर चढ़ जाता. Pipe does not apply any pressure. Viscosity is not pressure. Okay. Yes, Priyanshu. Good evening. Tell me. Do you think everyone who gets to IIT started preparing from 6th, 7th standard? Do you think people who start preparing from 11th and 12th cannot get into IITs? That's it. That's it. There is somebody getting into 500 or getting into anything is not the matter of when you start. It's how much effort you are putting. Definitely in the beginning. And by the way, let me tell you, when people start studying from foundation courses, they are not taught entirely what they should be studying from JEE point of view because of the age. At that age, you are limited. You have limited understanding of science, maths. So they are given foundation, which is basically giving a taste of problem-solving aptitude. You know that till 10th standard, you guys did not have that problem-solving aptitude. You were just only interested, or you were only asked to solve questions which were there in the textbook, the last exercise of the book, right? But in foundation courses, only thing that institutes try to inculcate is the aptitude to solve problems. While reading a question which is not from textbook also, but it is from some concept, have never been heard of, have never been seen of, putting yourself into that situation which is challenging. So in foundation courses, it's not course which is completed earlier. It is more of giving, you get more time. So there is no debate on that if you start from 9th standard, if you start from 11th standard, then definitely 9th standard guy is getting more time, right? But that guy, when he's getting time from 9th and 10th, most of that time is utilized in developing that problem solving attitude. You think that if you were starting with 9th and 10th and you completed your syllabus for the sake of completing, and then 11th and 12th you just redid that syllabus, will it just because of the time improve your performance? It will not, unless you develop a problem solving aptitude. And there are many students who do foundation course and they do not make it that big. Or let me put it this way, all India rank hundreds are not only people who have started from 8th, 9th or 10th standard. Okay. Completely भैया, ये तो बहुत data science based है, मतलब इसमें कोई analysis करनी भी है तो वो data science पे based होगी कि last 10 साल, last 5 years, 10 years, you take the data and then you will require that clarity also that who actually started preparing from 11th or started preparing earlier. And usually people don't create or maintain a data of that level. Okay. But all I can say based upon my experience that it is a myth to say that only foundation preparing students crack JEE with a good rank. Everyone has equal opportunity. Only thing that now that your time is also devoted to your school in also preparing for JEE, and you definitely you are still new to problem solving aptitude comparative to somebody who started preparing in say 9th or 10th. So yes, still you will have to push yourself in order to get into that aptitude of problem solving. Once you read the question, your mind starts thinking from solving point of view instead of thinking from formula oriented point of view. There are two types of students. One who think always इसमें क्या formula लगेगा, what formula do I apply in this one, and then the other one is that thinking about the question and what's exactly being asked in the question, and then figuring out okay, this is partially based upon laws of motion also, partially based upon fluid mechanics also, those kind of approaches. And that is why they say when we solve challenging questions in JEE, say I'm going to give it 3 minutes to solve. In those 3 minutes, if you take half of that time to just think and understand the question, that's absolutely fine. In fact, good students take time to understand the question rather than just start to write and solve the question. Okay? Yeah. So just eradicate this thought from your mind that you are starting from 11, so your chances of getting into good ranks are more. Just totally come out of that thought. Okay. Cool. Take care. So if I won't be getting rank of my desired branch as of rank of my recent college, I should consider taking a drop. Arshad, अभी 11th में हूँ. बाद में बात करेंगे ड्रॉप के बारे में. Okay. Yes, गौतम. हाँ ये बच्चा बोलो. Thank you, हाँ. मित्र सूडो फोर्स किस सिचुएशन में लगाया जाता है? हर जगह सूडो फोर्स होता है अगर तुम उस सिचुएशन में हो जहां जो बॉडी एक्सेलरेट कर रही है. अगर तुम उसके अंदर नहीं हो तो सूडो फोर्स नहीं है. हाँ तो सेंट्रीफ्यूगल फोर्स लगा देंगे. That's the property of mass. What is inertia? Inertia की वजह से सूडो फोर्स लगता है. We have mass, and when we accelerate, we get that feeling of our body does not want to move in that direction. Our body always pushes ourselves to stay in the state where we are. That is the property of mass. अगर वो एक्सेलरेशन वाले फ्रेम में है तो, अगर उसका फ्रेम एक्सेलरेट कर रहा है तो. Okay. Sir, how many marks is you suggest better in test? Is 200 plus is better or not? Usually, अगर I recommend, see, target, if you want to target, you target the best that you want to target, right? But I do not usually go, I'm a very practical approaching person. I always look at my own. Okay, Anshan, answer your question only. I always will look at my own performance and my own potential. So say on an average out of 300, I'm getting only 100 marks. So I will not start targeting directly 200. I will definitely try to bring this 100 to 120 and try to make it constant. Okay. Then in the next one, I'll try to make it 150, and then try to make it a constant there over the period of time in multiple tests. Like that, I will not be happy if I'm getting in one of the tests 250 plus and in the next test straight away I get a marks 100. If I'm getting a drop from 250 to 100, then I'm not happy. But if I'm getting an improvement from 100 to 120 and I'm never coming back from 120 down, then that is the performance that I consider better. Okay, Ansh? Yes, Gautam. नहीं आंसर दे दिया मैंने. नहीं, देयर इज अ डाउट ऐप फॉर दैट. एंड ये जो टाइम है ना, ये टाइम मैं एक्सटेंड इसलिए करता हूं ताकि जो क्लास मैंने पढ़ाई है मैं वो वाले डाउट्स क्लियर कर सकूं. दैट इज व्हाई. ओके. So try with the doubt app, try to solve, and मेरा सबसे बड़ा सजेशन, try to be in sync with what is happening in the class. Okay. मुझे नहीं सुनना. मैं सब बच्चों की बहुत बात सुन चुका हूँ ये सारी बातें. मैं सिंपली एक ही बात बोलता हूँ, देयर आर मल्टीपल एक्सक्यूजेस, देयर आर मल्टीपल रीजंस. अरे मल्टीपल रीजन भी बोला मैंने. कभी एक्सक्यूज होता है, कभी रीजन होता है. ठीक है. क्या हो गया? तो हैव यू स्पोकन टू योर सैम? तो सैम के थ्रू ही कराओ ना अपडेट. अच्छा ठीक है. नेक्स्ट वेंसडे, अगला अपना वेंसडे को सेशन आएगा. तब तक ट्राई टू हैव अ कन्वर्सेशन विद योर सैम बाय मे बी टुमारो और डे आफ्टर वेंसडे तक. तब तक नहीं होता है तो मुझे बताना. देन विल सी व्हाट वी कैन डू. है ना? इधर आई विल फॉरवर्ड योर क्वेरी आफ्टर दैट अगर तब तक नहीं होता है तो. ठीक है. यस. थैंक यू दीप सर. थैंक यू. यू कैन एग्जिट द क्लास. यस सर. सिलेक्शन का मतलब क्या होता है? मींस रैंक लेस देन 10000. सिलेक्शन का मतलब होता है कि आईआईटी तुम्हें काउंसलिंग के लिए बुलाने वाली है, या कोई भी कॉलेज तुम्हें काउंसलिंग के लिए बुलाया हुआ है. दैट्स व्हाट वी कॉल एज सिलेक्शन. So अभी जो जे एडवांस का रिजल्ट आया, the students who are qualified, they will be called by IITs for the counseling based upon their rank, based upon their preference. काउंसलिंग का मतलब होता है you fill your choice कि मुझे कौन से कॉलेज में कौन सा ब्रांच के लिए अप्लाई करना है. तो आप अप्लाई कर दोगे, आप तो चाहोगे कि आपको बेस्ट कॉलेज में बेस्ट ब्रांच मिल जाए. बट आपकी रैंक, आपकी चॉइस और आपका कॉलेज का चॉइस, उसका पूरा कॉम्बिनेशन होता है जिसके बेसिस पे आपको ब्रांच या कॉलेज मिलता है. अब बहुत बार क्या होता है, मान लो 10-11 हज़ार किसी की रैंक है और उस स्टूडेंट ने अप्लाई किया और उसे मान लो ऐसा कोई कॉलेज मिल गया जिसमें उसको नहीं जाना है, तो अब उसको तो अलॉट हो गया. तो उसको अलॉट हुआ, उसने ज्वाइन नहीं किया, तो जो उससे पीछे वाली रैंक वाला बंदा है जिसने भी वो अप्लाई किया होगा, इफ दिस गाय फर्स्ट गाय डज नॉट जॉइन, द सेकंड गाय विल गेट दैट कॉलेज. तो इसीलिए आपको जब इस प्रोसेस में जाते हो तो इसे काउंसलिंग कहते हैं. ठीक है. ना एसएसपी जैसा कुछ नहीं है. यस तुषार. जो भी तुमने ईमेल वगैरह किया हुआ है ना, तुम्हारे पास जो डिटेल्स हैं तुम्हारे पास होंगे ना सारे ईमेल्स अपने उसमें, उसको मैं तुम्हें ये भेज रहा हूँ. तुम्हें चैट बॉक्स में मेरा टेलीग्राम आईडी लिख रहा हूँ. मुझे सिर्फ वो स्क्रीनशॉट्स भेज देना. ठीक है. ये मेरा टेलीग्राम आईडी है. यहाँ पे मुझे स्क्रीनशॉट्स भेज देना. जो भी तुम्हारा कॉन्वर्सेशन हुआ है सैम से या किसी से भी हुआ है, वो तुम मुझे फॉरवर्ड कर दो. ठीक है. तो आई विल टेक इट फॉरवर्ड फ्रॉम देयर. मैं आगे भेजता हूँ. नहीं मैं किसी के डाउट्स नहीं लेता टेलीग्राम पे. ओके तुषार. आई डोंट गेट टाइम ओनली यार. ओके. मतलब क्लास में थियरी नहीं समझ में आती क्या निहाल? क्लास में थियरी समझ नहीं आती तो फिर उसके बाद में एनसीईआरटी और तत्व से थियरी पढ़ने का क्या लॉजिक है? सादे क्या ऑपरेशनल क्वेश्चंस मेरे से मत पूछो प्लीज. आई एम नॉट वेदांतोस ऑपरेशंस टीम हेड. आई एम ओनली अ टीचर. तो क्यों नहीं होते समथिंग दैट आई एम नॉट द पर्सन हु डिसाइड्स द पॉलिसी, राइट? सर बिफोर ओनली आई प्रिपेयर एंड कम दैट आई डोंट अंडरस्टैंड. यस निहाल. Obviously you will not understand things completely, obviously. It's better that you use that time to solve questions and do your work related to the class which was done earlier. Like now it will be more useful if you now go back and solve questions of that or do things from NCERT. First of all, for physics I don't recommend NCERT. Okay, and I don't recommend Tattva to read theory. Okay, and I'm saying this for enough time to you personally and to the class. In physics there is nothing called as theory. Especially in 11th, so far theory is like 1% of what entire 11th standard JEE preparation is. Theory is only 1 or 2% important to that. For the amount of efforts that you should be putting in 11th standard, only 1 or 2% of that effort should go to the theory. 98% should go to problem solving. Please do not read NCERT of physics. Okay. I'm talking about physics, and I do not comment about chemistry and maths. I'm again saying I do not recommend for physics. I don't want you to read it for physics. You did? Good. Keep it up. Just maintain this motivation. Okay. Yeah, okay. Awesome, Nihal. Okay. Bye bye. Janvi, you can solve that definitely. Your term 1 is going to be objective only, right? Term 1 is going to be objective, if I'm not wrong. So do solve MCQs only. It becomes easier, no? So मैंने से फिजिक्स क्वेश्चन आंसर किए, टेस्ट में पूरा रिजल्ट फिजिक्स पे बेस आया, ठीक है, गलत बातें लिखनी है, मैथ्स और केमिस्ट्री करना चाहिए. हाँ, बहुत लोगों का टर्म 1 हो भी गया, आई नो दैट, बहुत सारे लोगों का टर्म 1 एग्जाम हो भी गया, डिपेंडिंग अपॉन देयर स्कूल ऑब्वियसली. वेरी नाइस परिधि, वेरी गुड, है ना. स्कूल एग्जाम्स को बहुत ज़्यादा सीरियसली प्रेशर में मत देना. Means do not get into your school examination mode so much that you come out of JEE prep. Maintain both of them, balance both of them, but don't get too much into the school examination mode. I should not say that you should not take them seriously. You should take them seriously, but do not mentally get into that mode because that is where you are restricted to solving only the textbook questions, which is not good. Okay. I'm not saying to not study for school exams. I'm not even saying that. Mentally keep the boundaries clear. That what is JEE prep and what is school prep. Okay. I'm not saying don't appear for them or don't study for them. Study. Study. Give that time. Okay. Okay, everyone. So we'll call it a day here. We'll meet again. Wednesday we'll meet. Okay. Okay. Bernoulli. Bye bye. Bye everyone. I'll see you all on Wednesday. Take care. Bye guys. Signing off. Chalo. Bye guys.